Okay, so the first question we have says plot the points on the Cartesian plane, and it gives us a list of 4 ordered pairs, which are the points we need to plot on this graph. Now, you don't need to know exactly what a Cartesian plane is, you just need to know that it's this rectangular shaped graph where each of these ordered pairs corresponds to a point on this graph. So our first point, for example, is -4, 2. So if we go here, we count this first number is always going to be on the x-axis, which runs horizontally, and the second number in the ordered pair is going to be on the y-axis, which runs vertically. So we count 4 spaces backwards because it's -4, and this center point is the origin, meaning it's 0, 0. So any point in the negative will be to the any point in the negative x region will be to the left of the origin, and any point in the positive x region will be to the right of the origin. So we count 4 spaces left of the origin, 1, 2, 3, 4, and then because it's +2 will always be, positive y values will always be above the origin, and negative y values will always be below the origin. So because this is a positive y value, we count 2 spaces above the origin, and each of these pegs, by the way, represents 1 point on either the x or the y value. So we go up 2 spaces to here, and we make our little point there, and that's -4 too. And then so the next point is -3, -6, and so we count again 3 spaces to the left of the origin because it's a negative x value, and then we would go down 6 spaces below the origin because it's a negative y value. That's actually going to be off the graph, so we go 1, 2, 3, 4, 5, and then somewhere down here would be -3, -6. And then so our next point that we're given is 0, 5. So if you're given a 0 on the x value, it means your point is going to be somewhere along this y-axis, or on the origin if your point is 0, 0. If you're given a 0 in the y value, your point will be along this x-axis, or 0, 0 if both points are 0. So because the x value is 0, we know we're going to be working along this y-axis here, and our y value is 5, so we go up 5 because it's +5, meaning we go 5 above the origin. So we just count 5 spaces up here all the way to the top, and we put our little point there, which you can't really see, but just imagine it's there, I guess. Then our next point is 1, -4. So because the x value here is positive, we go to the right of the origin, just 1 space because it's +1, and then because our y value is -4, we go down 4 spaces from the origin. So we jump over 1, and then we go 1, 2, 3, 4 down here. And that's how you do that. So, for the next problem, we're given the same type of question, plotting the points in the Cartesian plane, but now we're given 4 different points. We have 3, 8, 0.5, -1, 5, -6, and -2, 2.5. So now that you've seen the last problem being done, I want you to try pausing this video and try doing these problems on your own, and when you think you've got it, you can unpause the video and we'll see how you did. So now I'm assuming you've paused it, done the problems, and now unpaused it, so now we're going to find the solution. So our first point is 3, 8. So we have to remember the first point here is always our point is always our x value, and because our x value is positive, we're going to be going to the right of the origin by 3 points. So we're going 1, 2, 3, and our y value is +8 because that's a second number, and because it's positive, we're going to be going 8 above the origin. So at this point 3, we have to go 8 spaces up, which will be off the graph because this last point here is 5. So we can just go 6, 7, 8, and ballpark it around somewhere right there. Our next point is 0.5, comma 1, or comma negative 1, I'm sorry. Because these x values, these pegs here, are scaled by 1, we are going to be going in between 0 and 1 to get 0.5. And then because it's negative 1, we will be going to the first peg below the origin because it's a negative y value. So I will draw this point right there. So that's our second point. And our third point is 5 comma negative 6, 5 being the x value, so we go 5 spaces to the right of the origin right here, and then we go 6 spaces below the origin because it's negative 6. That's again going to be off of the graph because this last point is negative 5, so we just go one more over there, and that is ballpark. That's around our point. And then our last value is negative 2 comma 2.5. So we're going to be going to the left of the origin this time because the x value is negative. So we go 2 spaces to the left of the origin, and then because our y value is 2.5, we go 1, 2, and then in between this second and third point is 2.5, so we go right there. And if it ever asks you to identify which quadrant a point is in, this is what you need to remember. This quadrant is quadrant 1, this square right here, or this L shape right here. This quadrant is quadrant 2, this backwards looking L right here. This quadrant is quadrant 3 right here. And then this quadrant is quadrant 4. So it goes like that, counterclockwise. Okay, so for this next problem, we are given the coordinate of the point in words, and we're asked to graph it and identify what that point is. So the first one we're given is the point is 3 units to the left of the y-axis and 4 units above the x-axis. Well, we know that this vertical line here will be the y-axis, so if it's 3 units to the left here, we go 1, 2, 3, which would be negative 3. And it's 4 units above the x-axis, which we know to be this horizontal line here. So we go 4 units above that, up here, and our point is right about there, and we can say that our point is negative 3, comma 4. Okay, so for the next problem, we're given that the point is 5 units below the x-axis and the coordinates of the point are equal, meaning that when we write the ordered pair, the value for the x should be the same as the value for the y. So we know it's 5 units below this vertical, or this horizontal line, the x-axis, so we count 5 units below that, and that would be our y value, negative 5. And because the coordinates of the point are equal, that automatically means that the value in the x position is negative 5 as well. So we go 1, 2, 3, 4, 5, and we count down 5 all the way to this bottom point over here. And then we say that our point is negative 5, comma negative 5. Okay, so for this next problem, we are asked to determine the quadrant or quadrants in which the ordered pair x, y is located so that the condition or conditions is or are satisfied. And the information we're given is that x is greater than 0 and y is less than 0. So we know that x is greater than 0 on this on this right side of the graph, I mean. Anything to the left here, to the left of this vertical line, would be a negative x value. So we can go ahead and just kind of mark this out to help us. So this whole space right here is where x is greater than 0. And if it said x is greater than or equal to 0, then this vertical line would also count here. But because it's just greater than, it doesn't count. And then our other piece of information is y is less than 0, which we know y is less than 0 anywhere underneath this horizontal line. So we draw lines like that to represent where y is less than 0. and we see that the only quadrant in which these two lines intersect is in quadrant 4. So our final answer is quadrant 4. Okay, so now the next question, or the question is the same thing, but we just get different information. And the information we're given is that x is equal to -4 and y is greater than 0. So pause this and try it on your own now that you saw how to do the last one, and then unpause it and we'll see if you got it. So x is equal to -4, which means it's 4 spaces to the left of the origin. So 1, 2, 3, 4, and it would just be a straight line running up and down at x equals -4. And just imagine that line straight, even though it's a little bit curved. And then y is greater than or y is greater than 0, which is anywhere above this horizontal line here. So we draw lines here representing all the values which y could be. And we see that the only quadrant in which the first and second condition are true together is in quadrant 2. So your final answer is quadrant 2. So now for this next problem, it is kind of different from the last two because it just gives us the information for the y. But don't get tripped up on that. That doesn't really change how you solve the problem. Basically, you would just kind of shade in all the areas where y is less than -5, and because we know that y would be negative below this horizontal line, it would be less than -5 kind of off the graph here. But as you can see, hopefully I'm drawing this in a way that's easier to see, y is less than -5 anywhere below here in quadrant 3 or quadrant 4. It wouldn't be less than 5 in 1 or 2, in quadrants 1 or 2, because in those areas the y value is positive. So for this one, your answer would be quadrant 3 or quadrant 4. Okay, so now in this next problem, we're given the information that x is less than 0 and -y is greater than 0. And the -y part might seem confusing at first, but you just need to kind of really think about it and think about what it's trying to say. So if we go over here, for example, and we do -y is greater than 0, this might look confusing at first, but in order to get it into a form that we can understand, we just need to divide by -1 so that y will be positive. So we divide by 1, and now positive y, and remember, when you're dealing with inequalities and you divide by a negative number, you always reverse the sign of the inequality. So that now becomes y is less than 0. So if we go back over here, -y is greater than 0 actually just means y is less than 0. So now we know x is less than 0, which we know is on this side of the graph. X is less than 0, and y is less than 0 as well, which is on this side of the graph right over here. So sometimes with problems like that, you just might need to take some time to think about it or get it into a form that you know how to deal with, that you know what you're working with. And we can see that these two lines intersect only in quadrant 3, so our answer would be quadrant 3. So in this next problem, we're given that x times y is greater than 0. So I'm just going to take the time to step through each quadrant and show what's going on in terms of x times y and like kind of how that relates to each quadrant here. So if we go to quadrant 1, where both the x is greater than 0 and y is greater than 0, we can pick any point for x and y. I'll just pick 1 to keep it simple, 1 for both. So x times y. So that means 1 times 1 is greater than 0. This is true. And we can do that for any number for x and y. We can do x equals 3 and y equals 3. And then we can say, is 3 times 3 greater than 0? That's true. So we know for any value in quadrant 1, and you can do this on your own with any value where x and y are both in quadrant 1, we know that for any value in quadrant 1, x times y will be greater than 0. So we can kind of highlight this section as being true. And I'll just make the intersecting pattern because we know this quadrant to be true right here. Now, in quadrant 2, our x value will be negative, but our y value will be positive. So let's do the same thing here. X will be negative 1, because it would be here, and y will equal 1. Now we do negative 1 times 1, and we ask ourselves, is negative 1 times 1 greater than 0? And we find that the answer is no, because negative 1 is not greater than 0. And we can do that with any number in quadrant 2. You can test that out with any number in quadrant 2, but because one number, the x value, will always be negative in quadrant 2, and the y value will always be positive, they will always result in a negative number, which will never be greater than 0. So we know that quadrant 2 does not, the points being in quadrant 2 doesn't satisfy this condition of x and y, x times y being greater than 0. Now if we go to quadrant 3, the x and the y values are both negative. So let's plug in negative 1 for x and negative 1 for y. And we ask ourselves, is negative 1 times negative 1 greater than 0? And we find that the answer is yes, because negative 1 times negative 1 is just positive 1, and 1 is greater than 0. And you can, again, do that with any value in quadrant 3, but because both the x and the y values are negative, and a negative times a negative number is always going to result in a positive number, which is greater than 0, we know that any value in quadrant 3 will satisfy the conditions we're given. So I'll just make this intersecting pattern here. And then we go to quadrant 4. So the x value is positive, but the y value is negative. So let's plug in positive 1 for x and negative 1 for y. And then we ask ourselves, is 1 times negative 1 greater than 0? And we find that just like in quadrant 2, the answer would be no, because a negative times a positive will always be a negative, and a negative is never greater than 0. So quadrant 4 does not satisfy the given condition, which means that only quadrant 1 and quadrant 4, only quadrant 1 and quadrant 3, satisfy the given condition. So in this next problem, we are asked to sketch a scatter plot of the data shown in the table. And in the table, we have a number of years going from 2000 to 2007, and a number of stores being opened, ranging anywhere from just over 4,100 to over 7,200. So we're told that the x-axis is going to contain the years. So I labeled the x-axis as such, with 0 corresponding to 2000 and 1 corresponding to 2001, so on and so forth until you get to 7 corresponding to 2007. And then the y values, I started at 4,000 and scaled it up by 500, so it goes from 4,000 to 4,500 to 5,000, so on and so forth, all the way up to 7,500. So our first year is 0, 2000, and the number of stores is 4,100, so we go just past the 4,000 mark, right about there, I'd say. Maybe even a little lower, actually. Probably around there. Then in year 2001, which corresponds to 1, we have 4,400 stores, so that would be just below the second peg on the graph, so it would be probably somewhere like right there. Then for 2002 we have 4,688, so that would be just after the peg, a little bit after the second peg, probably around there somewhere. Then for 2003 we have 4,906, so we go to this third peg here because that's representing 2003, and we go just below the 5,000 mark because it's almost 5,000 but not quite. And this doesn't have to be exactly perfect because it's a scatter plot. It doesn't say like make an exact graph or anything, so we can be a little bit off as long as we're not, completely all over the place. Then for 2004 our value is 5,289, so we go kind of not quite in between 5,000 and 5,500, but like just below the halfway mark is where I'd say, so probably right around there. Then 2005 we have 6,141, so we go, this is the 5,500 mark, and then this is the 6,000 mark, and it's just after that, so we go probably right there is what I'd say, 2006 or 2005. And then for 2006 we have 6,779, so if this is 6,000, then this one would be 6,500 right here, and it's a little bit past that, so I'd say right there is where I'd put it. And then our very last one in 2007 is 7,262, so that would be a little bit below the halfway. It would be a little bit below the midpoint between 7,000 and 7,500, so probably right around there. I would put it right there is where I'd probably move it more to the right to make it correspond better with 2007. Right there. And if you were asked to identify like a type of correlation, then this graph would have a positive correlation, because as the values on the x-axis increase, so do the values on the y-axis. So if you're ever asked about a correlation, that's how you'd know. It's a negative correlation if one value increases and the other decreases, and it's no correlation if it's just truly like randomized points. Okay, so the next question asks us to find the distance between the 2 points 6, -3 and 6, 5. Now, although you could graph these 2 points out and just count the distance between the 2 points, I'm going to show you how to do it doing the distance formula, because I think that's more useful and it's more versatile in case the lines aren't like close by each other or something like that. So if you don't know the distance formula, it's d equals the square root of x squared minus x, or x2 minus x1 squared plus y2 minus y1 squared, where d is your distance and x1 and y1 are your first set of coordinates, and x2 and y2 are your second set of coordinates. So I'm just going to write a little equal sign, pretend there's a d there, but you don't need to keep rewriting it all the way down. So we will take the square root of x2, which is 6. Let me write that a little bit better. 6 minus 6, which is x1, that squared, plus, and then y2 is 5, minus -3, and then all that squared. Now 6 minus 6 is 0, and 0 squared is still 0. So I'm not even going to bother writing that in the next step, because it's not going to affect our answer in any way if this is just 0. 5 minus a negative 3, if you ever subtract like if you go minus a negative number, it's really just like adding, so you can kind of think about it like this, and now it's 5 plus 3, so now we have, again, I'm not going to rewrite this because this is 0 squared, which is just 0. 5 plus 3 is 8, and then put a square right there, put a exponent right there. And it's important that you actually do the squaring instead of just canceling that out with the root here, because sometimes it will affect your answer, so just be sure to actually evaluate the exponent first. So 8 squared is 64, and the root of 64 is 8. So our final answer, the distance between these 2 points, is 8. Okay, so in the next problem we're asked to find the distance between -3, -1, and 2, -1. So -3, -1 is our x1 and y1, 2, -1 are our x2 and y2. And I rewrote the distance formula here just for quick reference if you need it, and this is just going to be a formula that you're going to have to memorize, but it does come from the Pythagorean Theorem, so if you know that, then you can kind of work your way to this formula. So I'll just write the equal sign and just imagine that the d for distance is on this side. So the square root of x2, which is 2, minus x1, which is -3. Let me rewrite that too. Plus y2, which is -1, minus y1, which is -1 as well. So this minus a -1 is basically the same thing as +1, so -1 plus 1 is 0, and 0 squared is 0, so I'm not going to bother writing that in the next step because it won't change our answer in any way. And this 2 minus a -3 will become kind of like 2 plus 3, so 2 plus 3 is 5, and 5 in parentheses squared will equal the square root of 25, and the square root of 25 is just 5. So the distance between those 2 points is 5 units. So in the next question we're asked to find the distance between the 2 points -2, 6 and the other point 3, -6. And just like last time, -2, 6 is our x1, y1, and 3, -6 is our x2, y2. So having seen the last 2 problems being done, I want you to pause the video and try this on your own, and we'll see how you do. So assuming that you've tried this problem, let's see how it's worked out. So I'm not going to write the d, just imagine it being there, and then the square root symbol. x2 is 3, so 3 minus a -2, and all of that squared, plus y2, which is -6, minus y1, which is 6, squared. We'll continue the square root symbol over there. And so 3 minus a -2 is the same thing as 3 plus 2. So this becomes 3 plus 2 is 5. 5 squared plus -6 minus 6 is the same thing as -12 squared. And this is what I was saying earlier, where you should evaluate the number being raised to the exponent. You should evaluate that instead of just canceling the squared symbol out with the square root, because if we canceled these squared symbols out with a square root, then we would get 5 minus 12, which is -7, and your distance can't be negative. So we have to evaluate the 5 squared and the negative 12 squared, and then add those together. So 5 squared is 25, and negative 12 squared is 144. And if you are wondering why this negative symbol doesn't carry over, it's because negative 12 squared is just negative 12 times negative 12, and a negative times a negative is a positive. So negative, or 25 plus 144 is 169. And the square root of 169, I believe, is 13. Oops, I didn't mean to write the root over there. It's just 13 units. Okay, so in the next problem we're asked to find the distance between the 2 points 1, 4 and negative 5, negative 1. So I want you to pause the video and try this on your own, and then we'll see how you did. So assuming that you've solved this, let's now step through it and see how you did. So the distance formula is equal to the square root of x2, which is negative 5, minus x1, which is 1, and that's going to be squared, plus y2, which is negative 1, minus y1, which is 4, and that's going to be squared. So negative 5 minus 1 is negative 6, and we're squaring that, plus negative 1 minus negative 4 is negative 5, so we're squaring that. And then this is going to be negative 6 squared is 36. And then negative 5 squared is 25. So we have that. And 36 plus 25 is 61. So these 2 points are the square root of 61 units away from each other. And you don't necessarily have to get this into decimal form. You can just say this answer, and that will be perfectly fine. Okay, so in this next problem, we're asked to find the distance between the 2 points 1/2, 4/3, and 2, negative 1. So just like in all the other ones, we're just going to plug in the numbers for x2 and x1 and y2 and y1. So in this case, x2 is 2. Oh, let me write that better. And x1 is 1/2. And that's going to be squared, plus y2, which is negative 1, minus 4/3, and all that is getting squared as well. So 2 minus 1/2 is 1.5, and if you need to see that, we can find the greatest common denominator, and that would be 4/2 minus 1/2. 4 minus 1 is 3, and the 2 would stay the same because, you know, we're subtracting 2 minus 1/2. We have to get the denominators to be the same, so we have to multiply 2 by 2 to make it something over 2, and 2 times 2 is 4, so it's 4/2 minus 1/2, which is equal to 3/2, which is 1/2 if you turn it into the mixed fraction, I believe it's called. So anyways, we have the square root of 3/2 squared plus, and then we have negative 1 minus 4/3. So if we just take that down here for a quick second, negative 1 minus 4/3. You cannot subtract these right now because they don't have equal denominators. So I'm going to multiply this by 3 over 3 and get negative 3 over 3, and that's still equal to negative 1. So this is still a valid statement I'm making here, minus 4/3. And now that they're equal denominators, we can subtract them, and negative 3 minus 4 is negative 7/3. So then we undo all of that and write negative 7/3 squared. Now, if you don't know, it's a property of exponents that if you have a over b, let me write those both better. If you have a and b, or a over b, and they're being squared like this, it's the same thing as a squared over b squared. And of course, a and b are just are variable names. I could have picked I or J or any letter, but this just means if you have any number over any number and they're both being squared, then it's the same thing as the numerator squared over the denominator squared. So when we have 3 over 2 being squared, it's the same thing as 3 squared over 2 squared. So 3 squared is 9. So 9 over, and then 2 squared is 4. Same thing with this. This is a 2, by the way. Hold on. So negative 7 squared is 49. And then 3 squared is 9. This is a 9. So we have 9 over 4 plus 49 over 9. So in order to get these equal, we have to get, or in order to add these, we have to make sure their denominators are equal. So a number that's 4 and 9 both can go into, off the top of my head, is 36. So we will multiply this by 4 over 4 in order to get the denominator equal to 36. And same thing over here, we're going to multiply it by 4 over 4. And that's going to give us the square root of, sorry, hold on. We're going to multiply this one by 9 over 9, because 4 times 4 would be 16, but 4 times 9 is 36. So now we're going to have, let me just draw this down here. The square root of 9 times 9 is 81. And then 4 times 9 is 36. Plus 49 times 4, I'm going to use my calculator for that because I can't do that in my head, is 196. And then 4 times 9 is 36. And then 81 plus 196, now that we can add the fractions together, is 277. Let me just draw that over here. Is the square root of 277 over 36. Now, a property of square roots, if you didn't know this, it's similar to the exponent one. If you have a variable a over variable b, and the square root is being taken of them both like this, It's the same thing as saying the square root of a over the square root of b. So this is the same thing here as saying the square root of 277 over the square root of 36. And the square root of 277 is a decimal number, so just leave it as the square root of 277. But the square root of 36 is 6, so we write that as 6. Oh, my bad. So your final answer would be that these 2 points are root 277 over 6 units away from each other. Okay, so for this next problem, we are given the 2 points negative 4.2, comma 3.1, and negative 12.5, comma 4.8, and we are asked to find the distance between these 2 points. And it's just going to be exactly the same as the previous ones we've done. So x2 in this case is negative 12.5, so negative 12.5 minus negative 4.2, which is x1, and then that whole thing squared, plus, and then we have 4.8, which is y2, minus 3.1, which is y1, and that whole thing is going to be squared. And let's carry over this square root sign. So negative 12.5 minus negative 4.2 is the same thing as negative 12.5 plus 4.2, which is, if we use our calculator here, because I don't know how to do that in my head, is negative 8.3. So this is the square root of negative 8.3. Let me write that better. Negative 8.3 squared plus 4.8 minus 3.1 is 1.7. So plus 1.7 squared. Now negative 8.3 squared is 68.89. So this is going to be the square root of 68.89 plus 1.7 squared, which is 2.89. So this whole thing, 68.89 plus 2.89 is 71.78. So this is the root of 71.78. And it's fine to leave your answer like this. This is still as valid as actually taking the square root of it. But if you do need to take the square root of it, then that would just be 8.47. So these 2 points are 8.47 units away from each other. Okay, so in this next problem we're given a triangle and the coordinates of each corner of the triangle, and we are asked to find not only the length of each side but also to prove that the lengths satisfy the Pythagorean theorem. So let's start with the first part, finding the length of each side. The first thing you're going to want to do, just to make it easier on yourself, is to label what each side is. So I'm going to label this corner right here, this 0, 2 point as A, this 4, 2 part as B, and this 4, 5 part as C. Now if we want to find the length of each side, we just have to find the length of these line segments, which is essentially what this is. This is 3 connected line segments, if you want to think about it like that. So for the first part, we have to find the length of we have to find the length of line AC. So to do that, to find the length of this line, all we would have to do is find the distance between these 2 points, because the line between them, the line connecting them, is the distance between those 2 points. So we go back over here and we write out our distance formula again, which is distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared, like that. So our x2 in this case would be 4, and our x1 would be 0. And our y2 in this case would be 5, because the point is 4, 5, and our y1 would be 2. Like that. Now we do 4 minus 0, which is just 4, and then 4 squared is 16, so we write that as 16, plus 5 minus 2 is 3, and 3 squared is 9, so like that. And then we do the square root of 16 plus 9, which is the square root of 25. And by the way, just like how you don't want to cancel out the raising to the second power here, you don't want to take the square root of 16 and the square root of 9 and add them together, because if you do that, you would get 4 plus 3, which it would lead you to the wrong answer, so don't do that. You want to evaluate what's under the root and then take the square root of that. So the square root of 25 is 5. So now we can say that the distance between A and C, between point A and point C, is 5 units. Like that. And then now we have to find the distance between point C and point B. So again, we write out the distance formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. So our x2 in this case would be 4, because the point is 4, 2. And then our x1 would also be 4, because it's 4, 5. So 4 minus 4 squared plus, and then y2 would be 2, and y1 would be 5. And then all of that squared. And then 4 minus 4 is 0, 0 squared is 0, so I'm not going to bother writing that again. 2 minus 5 is negative 3, so negative 3 oh, that looks a little floppy. Negative 3 squared, which is just the square root of 9. And the square root of 9 is 3. So point C and point B are 3 units away from each other. And then now we find the distance between point A and point B. So our x2 in this case would be 0 because the point is 0, 2. And then our x1 would be 4 because the point is 4, 2. And then our y2 would be 2 because of 0, 2. And then our y1 would also be 2 because the point is 0, 2, or 4, 2, I'm sorry. So 0 minus 4 will give us negative 4, so this will be the square root of negative 4. And all that's squared. And then 2 minus 2 is 0, and 0 squared is 0, so I'm not going to bother writing that. And then negative 4 squared is 16, so we have the square root of 16, which is 4. So the distance between the point A and B is 4 units. And then now for the second part of the question, we have to show that the lengths satisfy the Pythagorean theorem. Now if you don't know what Pythagorean theorem is, it says for any right triangle that you have, which this is a right angle right here, which makes it a right triangle, a squared plus b squared equals c squared. And c squared is the hypotenuse, which is the longest side of the triangle, and a and b are any of the supporting legs. So for this one, I'll call A 4, and I'll call b 3. So 4 squared plus 3 squared equals 5 squared. So 4 squared is 16, 3 squared is 9, and 5 squared is 25, and 16 plus 9 is 25. So we can say that 25 equals 25, and that the lengths of the legs of this triangle do support the Pythagorean theorem. So in this next problem, we're given the same instructions but a different triangle. And in this triangle, one of our points is at negative 1, 1, and our other point is at 9, 4, and our last point is at 9, 1. So having seen how to do the last problem, I want you to pause this and try it on your own, and then we'll see how you did. So assuming you've tried this, let's step through it and see how it's done. So just like last time, we have to find the distance between all of these points here in order to get the length of each side. So I'm going to call negative 1, 1 A, and 9, 4 B, and 9, 1 C. So first I'm going to find the distance between point A and point B. So, and I've already got the distance formula written out here in case you need it. So we do d equals, and then our x2 is going to be 9, minus our x1, which is negative 1, squared, plus y2, which is 4, minus our y1, which is 1, squared. So d equals 9 minus negative 1 is the same thing as saying 9 plus 1. So 9 plus 1 is 10, is just 10. So we're going to write 10 squared. And then 4 minus 1 is 3. So that's going to be 3 squared. And then 10 squared is 100. Plus 3 squared, which is 9. So this would be the square root of 109. And this doesn't go into any number evenly, so I would just leave it as the square root form and say that this side length here is the square root of 109 units. Like that. Now we have to find the length between point B and point C. So d equals the square root of x2, which is 9, minus x1, which is also 9. All of that squared, plus y2, which is 1, minus y1, which is 4, and that's going to be squared. And then 9 minus 9 is 0, and 0 squared is 0, so I'm not going to bother writing that down because it's not going to affect our answer. 1 minus 4 is negative 3, so this will be negative 3 squared, which is 9. So we have the square root of 9 here, and the square root of 9 is just 3. So this is going to be 3 units. And now our last thing to find the last 2 points to find the distance between point A and point C. So our x2 in this case is going to be negative 1, and our x1 is going to be 9. So we have negative 1 minus 9 squared, plus y2, which is going to be 1 because a point is negative 1 comma 1, and y1, which is 9 comma 1, I believe. Yeah, 9 comma 1. So 1 minus 1 squared. Negative 1 minus 9 is negative 10. So this is going to be negative 10 squared. And then 1 minus 1 is 0, and 0 squared is 0, so I'm not going to bother writing that down. And then negative 10 squared is 100, so we have the square root of 100. And then the square root of 100, when we finally take it, is going to be 10. So we can say that the point, or the distance between point A and point C is 10 units. And then in order to prove that these side lengths satisfy the Pythagorean theorem, we have to prove that a squared plus b squared equals c squared, where c is the longest side length on the triangle, which is called the hypotenuse, and it's of the right triangle. So a squared, we'll call that 10, or a will be called 10, so we'll have 10 squared, plus b, which we'll call 3. 3 squared equals the square root of 109, the square root of 109 squared. Now 10 squared is 100, and 3 squared is 9. And then just think about this here. So we have 109, this is basically saying the square root of 109 times the square root of 109. So if we multiply these together, what we'll end up having is we'll end up having the square root of 109 squared. I don't know what 109 squared is. We can do it real quick. So it's 11,881. 11,881. And because the square root is essentially asking which number under the radical is like multiplied by itself, I don't know how to explain it very well, but I will try. So the square root here is basically saying find a number that when you multiply it by itself, it gives you this number under the radical. So obviously the number that you multiplied by itself to give you 11,881 would be 109, because we just did that right there. So, and even if you do it on your calculator, you can see that the square root of 11,881 is 109. So all of that was just kind of a way to show you that this on the other side of the equal sign would just be 109. And 100 plus 9 is equal to 109. So we can say that the lengths of the triangle, the side lengths of the triangle, do indeed satisfy the Pythagorean theorem. Okay, so for this next problem, we're asked to show that the points form the vertices of the indicated polygon, and the indicated polygon is a right triangle, and we're given the 3 points 4, 0, 2, 1, and -1, -5. So to solve this one, what we're going to do is plot these points on the graph, and then find the distance between each point and prove that a squared plus b squared equals c squared, essentially, because we'll be forming a right triangle with the points, and then we have to prove Pythagorean's theorem, which is used on a right triangle to show that it is a right triangle. So our first point is 4, 0, so we go to the right of the origin 4 points right here, and we make our little dot right there. And then our second point is 2, 1, so we go to the right of the origin by 2 and above the origin by 1 point. So now we're there. And then our third point is -1, -5, so we go to the left of the origin, -1, and then go all the way down to -5. And then we connect these points. Imagine this is a straight line, even though it might not be the straightest. We just have to kind of make a rough sketch of it so we know what we're doing. So then presumably this would be the right angle right here. So we will call this point A, and this point B, and then this point C. So first let's find the distance between A and B. So our distance formula, if you don't remember, is D equals the square root of x2 minus x1, and all of that is going to be squared, and that's going to be added to y2 minus y1, and then that's going to be squared. So in this case, our x2 and y2 are 2, 1, and our x1 and y1 are -1, -5. So distance equals the square root of x2, which we said was 2, minus x1, which is -1, and then all that squared, plus our y2 is going to be 1 for 2, 1, minus a -5, and all that is being squared. And so 2 minus a -1 is the same thing as 2 plus 1, and 1 minus a -5 is the same thing as 1 plus 5. So in the next step we have 2 plus 1 squared plus 1 plus 5 squared. So 2 plus 1 is 3, and 3 squared is 9. So this is going to be 9. And then 1 plus 5 is 6, and 6 squared is 36. So like that. And then 9 plus 36 is going to give us 45, all under the square root. And this root can be simplified, but for the purpose of this problem, we're just going to leave the distance as root 45 units. Now, for the distance between point B and point C, again we have the same distance formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. And in this case, our x2 is going to be 4, and our x1 is going to be 2, and that's going to be squared. And then our y2 is going to be 0, and our y1 is going to be 1 for 2 comma 1. Let me write that better. Okay, so 4 minus 2 is 2, and 2 squared is 4. So this is going to be 4 plus, and then 0 minus 1 is negative 1, and negative 1 squared is 1. So that's going to be just 1. So then we have the square root of 4 plus 1, which is just the square root of 5. And we're going to leave it in that form and write 5 here. 5 here. And now we have to find the distance between point A and point C. So I'm just going to erase this so that we still have the distance formula written down in case you need it. So our x2 is going to be negative 1. And our x1 is going to be 4. And our y2 is going to be negative 5. And our y1 is going to be, let's see, it'd be 0. And then all that's going to get squared. So negative 1 minus 4 is the same thing as negative 5. Or it's not the same thing, it is negative 5. And then this would just be negative 5. So these are both getting squared. So we have negative 5 squared, which is 25, plus negative 5 squared, which is 25. And then we add those two together, and we get the square root of 50. And again, we're not going to simplify it, we're just going to leave it as the root of 50. So now that we have these distances, we need to prove that it's a right triangle. So to do that, we have to prove Pythagorean Theorem, which says a squared plus b squared equals c squared. And a and b and c in the Pythagorean theorem refer to the side lengths of the triangles, not the points right here. So c squared is the longest length of the triangle, it's the hypotenuse. So our c squared would be root 50, and then a squared and b squared, you can either call them root 45 plus root 5, or you can say root 5 plus root 45. Those things would be squared, by the way, because a squared plus b squared. But the main idea here is that you can switch the other two lengths around. It doesn't matter because addition is commutative. So a squared, we'll just call it root 45. So we have root 45 squared plus b squared, which is root 5 squared, and then c squared, which is root 50 squared. So basically what happens here is the raising to the second power, the squaring it, cancels out with the square root, because essentially what you're saying is root 45 times root 45, which would give you the square root of 45 squared, which just cancels out because a square root is asking for the number that when multiplied by itself it will give you the number under the radical here. So obviously because we multiplied 45 by itself here, this number would just be 45, if that makes any sense. So this would become 45, this would become 5, and then the root 50 squared would just be 50. And now we can tell just by looking at it, 45 plus 5 is 50. So we did verify that the vertices form the indicated polygon, but I noticed that I drew the right angle wrong here. I thought that the right angle would be here, but it would probably be here instead or something like that. But that doesn't matter. This was meant to be kind of just a rough sketch to give you an idea of what we're trying to do here. Okay, so in this next question we're asked again to show that the points from the vertices form the indicated polygon, and the polygon that we're asked to prove that the vertices form is an isosceles triangle. And what that means, if you don't know, is that two sides of the triangle are equal in length. So the points that we're given is the points we are given are the points we are given are 1, negative 3, 3, 2, and negative 2, 4. So first we're going to graph it, and then we're going to kind of see how we should go from there. So the point 1, negative 3, we move over from the origin by 1 point and then go down by 3. So that's 1, negative 3. And then we have 3, negative 2, so we go to the right 3 and up 2. And then negative 2, 4, we go to the left 2 and up 4. Right about there. And then we connect the dots like this, even though it might not look like a straight line at all. Just imagine it is, or use a straight edge to draw it. Hold on, let me draw this nicer. Alright, whatever. So let's call this point A, this point B, and this point C. So because it's an isosceles triangle, the lengths of two sides of the triangle have to be equal, meaning the distance between two of these points has to be equal. So what we're going to do is we're going to find the distance between we're going to find the distance between all of the points here, and then if we've done this right, two of the distances should be equal. So let's first find the distance between point A and point B. So we've already got the distance formula set up here, and our x2 is going to be 4, or negative 2, I'm sorry. Our x2 is going to be negative 2 minus our x1, which is 1, and that's going to be squared, and that's going to be plus our y2, which is 4, minus our y1, which is negative 3. Let me just make sure it's negative 3. Yep. So negative 2 minus 1 is the same, or negative 2 minus 1 is negative 3. So that's negative 3 squared. And 4 minus a negative 3 is the same thing as 4 plus 3. So 4 plus 3 is 7. And that's 7 squared. And then negative 3 squared is 9. Plus 7 squared, which is 49. And then that will give us 58. The square root of 58, I mean. So this distance is 58. Now let's find the distance between point B and point C. So x2 is going to be 3. And x1 is going to be 1 or -2. And then y2 is going to be 2. And y1 is going to be 4. So 3 minus a -2 is the same thing as 3 plus 2, which is 5. So we have 5 squared. And then 2 minus 4 is -2, and -2 squared is 4. So 5 squared is 25. And that's going to be added to 4. And that's going to equal the square root of 29. So if we've done this problem correctly, the distance between point A and point C should either be the square root of 58 or the square root of 29. So now our x2 is going to be the x value for C here, which is 3. And then our x1 will be 1. That's going to be squared. And then our y2 is going to be 2. And our y1 is going to be -3. Hold on. And that's going to be squared. So 3 minus 1 is 2. So 2 squared. Plus 2 minus 3 is, or 2 minus a -3 is the same thing as 2 plus 3. So that's going to be 5 squared. So 2 squared is 4. And 5 squared is 25. Which gives us the square root of 29. So then we go over here and we'll write down the square root of 29. And we can see that two distances here are the same, meaning that these two lengths are the same, meaning that this is indeed an isosceles triangle. Okay, so in this next problem we're asked to do 3 things. We're asked to plot the points given, find the distance between the points, and find the midpoint of the line segment joining the points. So let's start off by doing this first part, plotting the points. So the first point we're given is 1, 1. So we go 1 space to the right of the origin, and then 1 space above the origin to get that point right there. That's 1, 1. Excuse me. Then the second point is 9, 7. So we go to the right 9 spaces from the origin, all the way here. And then we go up 7 spaces from that point. So it will be kind of off the graph a little bit, because this point is 9, 5 here. So we just have to go 2 more, which would be about there, is my estimate. Now we have to find the distance between the 2 points. So if you don't remember the distance formula, it's d equals the square root of x2 minus x1, and that's going to be squared, plus y2 minus y1 squared. So in this case, our x1 and y1 are 1 and 1, and our x2 and y2 are 9 and 7. So for our x2, we're going to write 9, and then for our x1, we're going to write 1. So 9 minus 1 squared plus y2 is 7 and y1 is 1. So that's going to be squared. So distance equals the square root of 9 minus 1 is 8. So this is going to be 8 squared plus 7 minus 1 is 6. So this is going to be 6 squared. And then 8 squared 8 squared is 64. And 6 squared is 36. So it's the square root of 64 plus 36. And 64 plus 36 is 100. So distance equals the square root of 100. And the square root of 100 is 10. So the square, or the distance between these 2 points, is 10 units. Now it says find the midpoint of the line segment joining the points. So basically what it's asking us to do is draw a straight line from one point to the other, and just imagine that's a straight line, and find the point in the middle where, like if I plot the midpoint for here, right here for example, the distance from this point to that point is the same as the distance from this point to that point. Basically, a midpoint is the point in the middle of 2 points where it's equidistant from both points. So the midpoint formula, if you don't know, is m equals x1 plus x2 divided by 2, comma, y1 plus y2 over 2. And the reason we put the comma there is that once you plug in these numbers and evaluate it, it will be automatically in an ordered pair form, so you know where to plot it on the graph. So our x1 is just 1, and our x2 is 9. So 1 plus 9 over 2, comma, y1 is 1, and y2 is 7, and that's going to be over 2. And so 1 plus 9 is 10, and 10 divided by 2 is 5. So our x-coordinate is going to be 5 in that ordered pair. 1 plus 7 is 8, and 8 divided by 2 is 4. So our midpoint lies on 5, comma 4. So if we go 1, 2, 3, 4, 5, and then we go up 4 right here, we see that our midpoint is right here. So if I had drawn the line more accurate to what it was supposed to be, then that would be the midpoint. My line that I drew here and the point here is inaccurate, but I was just giving a sketch to give the idea. And you can see here we're finding, because we're adding 2 numbers and then dividing by 2, we're finding the average, like the average between those 2 points. So it might make sense or it might not, but basically the midpoint is just the point in between these 2 points. So you find, I don't know if that makes sense. Okay, so in this next question, we're given the same instructions, but a different set of points. We're given -4, 10, and 4, -5. So I want you to pause the video right here and try this on your own, and then unpause it when you're finished, and we'll see how you did. So assuming that you tried this problem on your own, let's go through the problem now, and we'll see if you got it right or if you made a mistake somewhere. So the points that we're given are -4, 10, and 4, -5. So we go to the left of the origin 4 points for this first ordered pair. 1, 2, 3, 4 over here. And then we go up 10, which is going to be way off the graph, way off this page even. So I'll just indicate that it's somewhere up there. Excuse me. And then our next point is 4, -5. So we go to the right of the origin 4 spaces and then down 5. And our point would be right about there. Let me move it over a little bit. Our point would be right about there. So now we have to find the distance between the 2 points. Again, this is our distance formula. If you don't remember it, it would be good just to memorize it. Just keep writing it down and getting that repetition in there so that you will be able to memorize it. So our x2 value is 4, and our x1 value is -4. So we have 4 minus -4 squared plus our y2 value, which is -5, I believe, minus 10, and that's going to be squared. So 4 minus a -4 is the same thing as 4 plus 4. So this is going to be 8 squared. And then -5 minus 10 is the same thing as -15. So this is going to be -15 squared. So now we have the square root of 8 squared plus -15 squared. 8 squared is 64, and -15 squared is 225. 64 plus 225 is 289, and the square root of 289 is 17. So these points that were given are 17 units away from each other. And it makes sense because this one is way off the graph and this one is way in the negative zone on the complete opposite side of the graph. So it would make sense that they're this distance away from each other. So for the midpoint, we go to the midpoint formula. And again, this is just something you're going to have to memorize. So I recommend that you practice writing it over and over and keep repeating it to yourself. Maybe make some mnemonic devices if that helps. So our x1 value is -4, and our x2 value is 4, and that's going to be over 2. And then we put the comma, and then our y1 value is -5 plus, or I'm sorry, our y1 would be 10. That doesn't really matter, but our y2 value would be -5, and then that's going to be over 2. So our midpoint is going to be -4 plus 4, which is 0, 0 over 2, comma 10 minus 5, which is 5 over 2. Now, in math, you're probably taught that you can't divide by 0, and so you might write this, or you might put this down as an error, but it's actually not. When you have a fraction and it's 0 over anything, it could be 1, or it could be 2, or it could be x, it could be a function of something, or like it could be a trigonometric function. 0 over anything, in this case I'll just put 1 to make it easier, is 0. If you have any number like 1 or 2 or x or sine of x, over 0, in this case I'll just put 1 to make it easier. If you have any number over 0 in a fraction, then it's undefined, which you can just write as UND. So in this case, 0 over 2 would just be 0, and then 5 comma 2, you can just leave it as 5 comma 2, or you can write 2.5. So our midpoint is at 0 comma 2.5, which is 0 comma 2.5, which is right here. So if you were to connect these 2 points with a line segment, the distance from -4 comma 10 to 0 comma 2.5 is exactly the same as the distance between 4 comma -5 and 0 comma 2.5. Alright, so for the next problem, we're given the exact same instructions, just different points. This time we're given the points -1 comma 2 and 5 comma 4. So now that you've seen how to do the last two, I want you to pause this video and try it on your own, and then we'll come back and see how you did. So assuming you've already tried the problem, let's see how it would be done. So our first point that we're given is -1 comma 2, so we go to the left of the origin by 1 space and then up 2. So that's our first point right there. And our next point is 5 comma 4. So we go to the right of the origin 5 spaces and then we go up 4. Like right there. So now we have to find the distance between the 2 points. I've already gone over the distance formula a lot already, so I'm not going to bother saying it. If you don't know it, just repeat writing it down until it's stuck in your head. So our x2 in this case will be 5, and our x1 will be -1. And then that's all going to be squared. And our y2 in this case is going to be 4, and our y1 is going to be 2. So that's going to be squared. So 5 minus a -1 is the same thing as 5 plus 1. So this is going to be 6 squared. And 4 minus 2 is 2, and 2 squared is 4. So this is going to be, or 4 minus 2 is 2, so we're just going to write 2 squared for the time being. So 6 squared is 36, so this is going to be the square root of 36 plus 4, which is going to give us the square root of 40. So you can either leave this as the square root of 40, or you can take it into decimal form, or you can simplify it, because the square root of 40 is the same thing as root 4 times root 10, and the root of 4 is 2. So you can either write root 40 or 2 root 10 or the decimal of 40. Or the decimal of square root 40, depending on what your teacher wants or what the book says. So we can say that the distance between these 2 points is the square root of 40 units away from each other. Now for the midpoint, once again, it's x1 plus x2 over 2, comma, y1 plus y2 over 2. So our x1 in this case is going to be -1, and our x2 is going to be 5, I believe. Yep. and our y1 is going to be 2, and our y2 is going to be 4. So -1 plus 5 is 4, and that's going to be over 2, and 2 plus 4 is 6, which is going to be placed over 2 as well. So 4 over 2 is 2, or 4 over 2 is the same thing if you don't know. It's the same thing as 4 divided by 2. So 4 over 2 is 2, and 6 over 2 is 3. So the midpoint of these 2 points is 2, 3. So at this point, at 2, 3, this length here is the same as this length over here. Even if it doesn't look like it, it may be because I drew the graph inaccurately, but you just need to know that's what the midpoint means. Okay, so for this next problem, we're once again given the exact same directions as the previous ones, just with different points. And our points this time are 1/2, 1, and -5 halves, 4/3. So to plot this first point, we're going to go to the right 1/2 and up 1 to this point right here. And then for the second point, we're going to go to the left 5 halves and up 4/3. So if you're ever unsure on how to graph fractions like 5 halves or 4/3, just remember that since each one of these segments is 1, it will be like, for example, this x-coordinate is 5 halves. So this first peg over here is the same thing as 2 over 2. That's the same thing as 1. Or -2 over 2, I suppose, because it's -1. And then this second point would be -4 over 2, because that's -2. This third peg would be -6 over 2, because that's -3. Well, we don't want -6 over 2, we want -5 over 2. So it would be in between this -6 over 2 and -4 over 2. So it would be -2.5 in other words. And then for the 4/3, since this peg is going up by 1, this is 3/3. And then this around here would be 4/3. So our point would be right about there. So then we have the distance formula. So d equals our x2 is going to be -5 halves let me write this better. -5 halves minus 1/2. And that's going to be squared plus our y2, which is 4/3 minus 1, and that's going to be squared. Now notice that these two denominators are not the same. Since it's 1, it's technically 1 over 1, and you cannot subtract fractions unless they have a least common multiple, which means their denominators have to be the same. So in order to do that, we'd have to, let me write it down here. In order to get 1 over 1 to equal or to have a denominator of 3, we have to multiply this whole fraction by 3 over 3 to get 3 over 3. Now the denominator is still, the denominator now is 3, meaning we can subtract them. And 3 over 3 is still equal to 1, because that's just how division works. If you divide a number by itself, it will equal 1. So we haven't changed this 1 over 1. This is still equal to 1. So instead of writing it as 1 over 1, I'm going to write it as 3 over 3 now that you saw why we would do that. So that's all going to be squared. So negative 5 over 2 minus 1 over 2 is the same thing as the square root of negative 6 over 2. And that's going to be squared. Plus 4 minus 3, or 4/3 minus 3/3, well, you subtract the numerator but keep the denominator the same. So 4 minus 3 is 1, and then the 3 would be the same. And then square that. Negative 6 over 2 is the same thing as negative 3. So this is going to be negative 3 squared. And 1/3 squared, if you don't remember, a property of exponents is that if a fraction is being raised to an exponent, that exponent distributes to the numerator and the denominator. So it's like saying 1/3 squared is the same thing as 1 squared, which is just 1, over 3 squared, which is 9. So negative 3 squared is equal to 9. So now we're left with the square root of 9 plus 1 over 9. Well, in order to get 9 to have the same denominator as 1 over 9, we have to multiply 9 over 1, which is what this technically is. We have to multiply that by 9 over 9 to get 81 over 9. Now the fractions are the same, they're both over 9, and the value 9 is the same thing as 81 over 9, because 81 over 9 is the same thing as 9. So I'm just going to rewrite 9 as 81 over 9. And that's going to be plus 9, or plus 1 over 9, I'm sorry. So that's going to be the square root of 82 over 9, which is the same thing as the square root of 82 over the square root of 9. And I'm sure 82 divides into some other number that you can take the square root of. I'm just going to leave it as root 82 for now. And the square root of 9 is 3. So the distance between these 2 points is the square root of 82 over 3 units. Now for the midpoint, we have x1, which is 1/2, plus x2, which is negative 5/2, and that's going to be over 2. And we're going to put the comma there. And y1 is 1. Or actually I'm going to write 3/3 because y2 is 4/3. And all of that over 2. So 1/2 minus 4/2, or 1/2 minus 5/2 is negative 4/2. And that's going to be over 2. And then 3/3 plus 4/3 is going to be 7/3. And that's going to be over 2. So negative 4 over 2 is negative 2. So we have negative 2 over 2. 7/3 divided by 2 is the same thing as 7/3 times 1/2. And the reason for that is division is the reciprocal of multiplication. Meaning, if you're dividing by 2, which is what we're doing here, we can change it to multiplication by kind of inverting what 2 is, or making the not the opposite, but flipping where 2 is. So 7/3 divided by 2 is basically the same as 7/3 divided by 2 over 1. So in order to change it to multiplication, we have to flip the numerator and the denominator of 2, which would make it 1/2. So -2 over 2 is -1, and when you're multiplying fractions, you multiply both the numerator and the denominator, so 7 times 1 is 7, and 3 times 2 is 6. So the midpoint of these 2 points is -1, 7/6. Okay, so in this next problem we're given the exact same instructions, but again, just different points. And the points we're given now are 6.2, 5.4, and -3.7, 1.8. So pause the video, try this on your own, and then unpause it and we'll see how you did. So now that you've tried the problem and unpaused the video, let's step through this and see how it's done. So our first point is 6.2, 5.4, so we go over 6, right about here, and just a little bit more for point 2. And then we go up 5 and almost to the halfway point between where 5 and 6 would be, but just below that because it's 4. So right around there is where I'm ballparking it. And then our next point is -3.7, 1.8. So we go to the left of the origin, 3.7 units, so 3, and then we go almost to 4, but not quite, and then up 1.8, which would be very close to 2, but just below it. So those are our points there. Now we have to find the distance between the 2 points. So our x2 is going to be -3.7 minus our x1, which is 6.2. And then that's going to be squared. And then our y2 is going to be 1.8. And that's going to be minus 5.4. And all of that's going to be squared as well. So then we have to do -3.7 minus 6.2, which I'm going to use my calculator for because I don't know that off the top of my head. It's -9.9. And then that's going to be squared. And then 1.8 minus 5.4. I again don't know that off the top of my head. But it's -3.6. And that's going to be squared. So then we have to do -9.9 squared, which is probably going to be 81.81 if I had to guess. No, it's 98.1. That's why you should use a calculator for problems that you don't know off the top of your head. So it would be 98.01. And then -3.6 squared is going to be it's going to be 12.96. So 12.96 plus 98.01 is 110.97. So you can either leave your answer like that or write what it is in the decimal form, which would be 10.53. So either one of these ways works, but the distance between these 2 points are 10.53 units is the main takeaway. Now to the midpoint, x1 plus x2 over 2 and y1 plus y2 over 2. So our x1 was 6.2, yep, 6.2 minus negative 3.7, so just minus 3.7 over 2, and y1 is 5.4, and y2 is 1.8, and that's going to be all over 2. And then 6.2 minus 3.7 is 2.5. And that's going to be over 2, comma 5.4 plus 1.8 is 7.2. Over 2. So 2.5 over 2 is 1.25. And then 7.2 over 2 is 3.6. So that would be your midpoint.